Hi, everyone, and welcome to this session. So I'm going to cover some of my work that I've been doing in the cybersecurity domain, and more specifically in the cloud security domain. So the outline that I will go throughout this session is I'm going to address some of the challenges that we face in the cybersecurity and in the cloud security domain. Some of the open issues or hot issues that we face when we migrate our on-premises infrastructure to the cloud from a cybersecurity perspective. And then we're going to also touch on the human factor and AI impact in cybersecurity and also in the labor market. So we've done some study on that. And I will conclude with the title of my talk, which is a collective intelligence framework for cloud security and forensics. So a little bit background about where this talk came from, and just to help us to be all on the same page about what I mean by cloud computing or cloud migration and cloud security issues that I will touch upon during this session. So usually when we say cloud, we refer to the scalability nature of the tools. So when we say about a tool that it's cloud native, then we refer to the scalability. It can scale up or down based on the need. And then in the context of what I'm going to be covering, it's the cloud migration, where most of our organizations now, they prefer not to have the physical infrastructure on the on-premises, but rather than that, we rent our resources, our servers from cloud providers, which will give me a lot of advantages, including but not limited to the advantages that we see here on this slide, including scalability, innovation, and many more advantages. But the challenge here becomes is that when we migrate our on-premises to the cloud, most organizations, they go to multi-hybrid cloud, where they have some of the applications still on the on-premises and some of the applications in the cloud, and they choose to go to multi-cloud, where they put some of the applications, for example, in Amazon Web Services, some in Microsoft Azure, some in GCP or Google Cloud Platform. And most of the organizations that I worked with, even before I joined academia, I worked as a cloud security engineer in Farmers Insurance, Palo Alto Networks, and Dell. They go to multi-hybrid cloud for many reasons, which are to avoid vendor lock-in, to have a better disaster recovery plan, to have the better service for the task in hand, and so on. Then the challenge becomes is in this highly distributed infrastructure and in this multidimensional infrastructure, how we can manage security and how we can apply security in a dynamic and in an intelligent way, so we don't end up having what we call a denial of wallet, because considering the scalability nature of the cloud, then if there is any successful cyber attack, then they can actually take advantage of that scalability nature, where they can run your resources for crypto mining and some other cyber attacks that will lead to many of the cloud unique challenges or cloud unique cyber attacks. Now, the challenges that I noticed when we work on the cloud security domain, including but not limited to this list, is as part of the cloud security team, we are part of a bigger team, which is the Cloud Center of Excellence, where we have to address cybersecurity with other teams, with our developers, infrastructure team, architecture team, contractors, and so on. And then we, of course, invest a lot of time in addressing the tasks and then the responsibilities per each team. But the focus of this task will be on the security part, and more specifically on the customer side of the shared responsibility model published by the cloud providers. So this is the shared responsibility model published by Microsoft Azure. This is the one by Google Cloud, and this is the one by AWS. They all say the same thing, that the security of the cloud is their responsibility, while our responsibility is the security in the cloud. So what we put in the cloud is what we're really going to be focusing on. which include this part up here. And this is what we focus on when we talk about cloud security from either researcher perspective or from even industry perspective. So some of these tasks that, or some of these projects that we work on is the Identity and Access Management, or IAM, which is, just to give you a little bit insight of the challenge that we face when we manage the responsibilities, the roles of our users in the cloud, is that if we have application, and this application we want to migrate to the cloud, and then for each application, when we migrate to the cloud, we have to create multiple environments. So there will be one environment for sandbox, one for staging, one for testing, one for production. And then per each one of these accounts, there will be multiple users. And then this is only for one single application. And then one of the migration projects I worked on, there was over 600 applications. And then you can imagine, now you do the math, and then you can imagine the large number of users that we need to really address, and we need to make sure that we want to apply least privilege determination. We want to make sure that our users can access and view what they need to access and view. And we automate the deployment using Terraform, which is an infrastructure as a code, but then the challenge becomes least privilege determination. And the real problem here is that if we want to centralize the least privilege determination in our cloud security team, then this can be infeasible, because to be able to secure that or to be able to apply that, we have to understand how all these application and all these environment works in order for us to understand the API calls that our developer need. And then if we do it in a decentralized approach, where we say we're going to give each account owner an admin account where they take care of the distribution of roles and responsibilities, then this may also violate the security principles. And then the collective intelligence approach that we followed at that time is that we worked with our developers to collaboratively reassess and reevaluate our least privilege determination by reading the logs, and then based on the API logs, we actually provide, or we developed a tool that will provide 3 types of findings. So our tool will read the logs, and then based on the logs, we will determine if there is any permission that was attempted but failed. Then we know that this permission is needed. Then maybe we reassess, we reevaluate, we reach out to the developers to do that. And then if there is some permissions that were granted and used, then we know these are the right ones. If there are any permissions that were granted but not used, maybe these are the ones that we need to eliminate. And then the tool will read that and will do reevaluation and will reassess based on that. But my core experience was on the vulnerability assessment domain in the cloud security, where we faced also some of the challenges, like, for example, the dynamic onboarding of cloud accounts. So when I say vulnerability assessment, when I connect this vulnerability assessment tool to my cloud infrastructure, it will read the vulnerabilities, and it will read my resources, it will read my configuration, and it will provide me with visibility of where I am at based on comparing my infrastructure, my configuration to best practices, to ISO, NIST, and the policies that we have defined also in the vulnerability assessment tool. And then based on that, it will give me some visibility about where I'm at, and then some remediation techniques. Then the challenge is, how can I do that in a dynamic way, where if I add any cloud account, any cloud environment, it will be reflected there, and vice versa. And the read-only versus read-write permission, and this is one of the key challenges when we think about AI in cybersecurity and AI in vulnerability assessment, because if we want to leverage AI and we want to say that to our vulnerability assessment tool. If you find something vulnerable, just fix it on the spot, because I want to give you the read-write permission and I want to be very secure. So you find vulnerabilities and then you patch it. This can be very secure, but of course, this is the option that none of the organization usually go to, because fixing a security vulnerability can break the code functionality and can break the availability of our application and can introduce some of the new challenges. And so we go with the read-only usually permission, but of course, this also stress the need for some AI techniques that will act like a human expert, where we can do this vulnerability assessment in an automated way. And then if we want to do it in a read-only permission, then this can introduce some of the challenges that we also introduced, we also addressed in the framework that I will be presenting at the end, which is alert fatigue. And believe it or not, most of the cybersecurity incidents that were actually successfully attacking some of the infrastructure or some of the big organizations or some of the big cyber attacks that we hear about really come from the large amount of false positives and the alert fatigue that will prevent us from investigating real incidents and paying attention to the logs and the alerts that we need to pay attention to. So the challenge here is how we can apply AI to really reduce the noise in our logs, and how we can do that in a way that will help us to focus on real true positives is a real challenging problem. And the challenge here is, especially when we do forensics or investigation, is that when we reduce the noise or when we reduce the amount of false positive, there will be a probability where some of these logs that we eliminate hold the evidence that we need to solve the whole problem at hand. And then it has to be done in a way where we do it in a hierarchical way, where we make sure we don't delete some of the true positives, while also providing some tools to minimize the false positive and reduce the risk of alert fatigue. So some of the frameworks or some of the flowchart that we developed at that time is that we also work with our developers to address vulnerabilities based on the priority or based on the severity level, and then we work on them on remediating that in a read-only format, not in a read-write format, where depending on the priority of that vulnerability, we remediate it. And of course, if it's a medium severity vulnerability in a production, it's going to be a higher priority comparing to, let's say, high severity vulnerability in a sandbox. So the environment will play a role in also coming up with this priority here. So we collaborate with our developers on that. We integrate also some of the tools to be able to give us better insights. So in cybersecurity, it's really significant to come up with this collective approach where our tools talk to each other. So for example, if I want my compliance tool to give me a better insight about my compliance score, then I need to connect it to my vulnerability assessment tool to be able to give me insight about where I'm at in terms of compliance based on the vulnerabilities that I have in my environment. Now, the thing that I want to spend the remainder of time addressing is DIFR, or digital forensics and incident response. And the challenging part here when we talk about forensics is, for example, if you have any of these incidents, if you have any cyber incident or cyber attack in your environment, and then you decided that you want to contain this incident by terminating that resource. So for example, you have a web server and you found out that this web server has some malware and it's part of a network, and then you have some concerns that this malware will move to other resources in that network, and then you decided that you want to contain that, you want to stop the bleeding by turning off that web server. So in the on-premises infrastructure, this can be an okay step to contain the incident, to stop the bleeding, because you can actually walk to the server's room, and then you can take a copy of that hard disk, and then you can do your investigation to come up with the root cause analysis to understand what happened, why this happened, and then to build your incident response runbook based on that. But in the cloud domain, this is completely different, because once you contain the incident by turning off or terminating these resources, then you actually lost access to most of the data, and you might not be able to do your investigation. You might not be able to understand what happened. And then the challenge here becomes how we can have a predefined isolation policies that will take care of the isolation and of the containment without jeopardizing losing some of the forensics data. So what we do here is we predefine our security policies in a way that says, if there is any web server that is communicating with, or that I suspect that it has some malware, then I will attach this isolation policy to that server, and I will not touch it. I will not turn it off, because this isolation policy will prevent any traffic from coming in or coming out from that server. And then I take care of the containment, but at the same time, I still have full access. I can do my investigation, and I can figure out what happened, and I can also do my forensics investigation. So when we do our incident response, we usually follow some of these steps, how we can prepare, how we can detect. And what I mentioned is fits into the step number 3, which is containment, eradication, and recovery. And more challenging aspects. Yes, Jacob? No. Okay. So this is actually one of the challenges that we face in also cloud security, is that you don't have access to all the logs. And this really depends on the deployment model, whether it's infrastructure as a service, platform as a service, or software as a service. But what I explained so far fits under the infrastructure as a service, where you launch your virtual machine, and then you choose the operating system, whether it's in AWS, Azure, GCP, and then you put your data, you put your applications. So you are responsible about managing all of these components, and you are responsible about collecting the logs for these services. And then the challenge becomes is not only that I don't have that some of these logs has to be pre-configured and predefined to be able to collect it, but also some of these services may exist temporarily in the cloud infrastructure. So how can we do this collection and retention? Can be something that we really need to do in the preparation before we even have some incidents in our infrastructure. So again, some of the most challenging things, and this is one of the things that we noticed after we implemented a cloud forensics project that was funded by NIWC Pacific, Naval Information Warfare Center in Hawaii and San Diego, where we work on cloud forensics project. And our preliminary data found that one of the most challenging aspects is false positive. And this is one of the things that I will include also as part of the framework that I will conclude with. But how can collective intelligence really play a role in reducing these false positive is the thing that I'm interested in solving throughout the framework. Now, we did not forget also about the human factor. So I came from an interdisciplinary background. I have my bachelor, my master, my PhD in computer science, but I also have another master's degree in management and in public administration, where I studied labor market. And I also know that it's really important to understand the challenges, not only from technical perspective, but also how AI may impact labor market, including but not limited to the cybersecurity job titles and the cloud security and forensics. So my collaborators and I conducted a study not only on labor market when it comes to technology and cybersecurity, but we did it on a larger scale where we leveraged the ONET data to understand how AI may impact labor market, and then to provide some type of recommendations to policymakers and to educations and to some other aspects of how we can be prepared to that shift. So in the 90s, we know that technology transformation impacted labor market, and then we anticipate that AI may also impact labor market positively and also may replace or may disrupt some of the job titles. So what we did here is we have this data set that has 20 industries and then also over 900 occupations, and it's widely used by the research community. It's called ONET, and this is the data structure for this, where in each occupation, they will give you some information about the occupation description and then also technology skills, some of the hot skills, and the industry. And it has more than 900 occupations. And some of these occupations may also be in more than one industry here. So what we did is we designed prompts to analyze that, and then this is one sample of the prompts, but we basically give it a persona, context, output, and evaluation, and we ask if you are a researcher in the field of labor markets, and you are interested in the extent to which AI technology can enhance work efficiency in different occupations. And please consider all kinds of artificial intelligence technologies, such as generative AI, robotics, natural language processing, computer vision, reinforcement learning. And the output will be to the extent to which AI can help workers improve the efficiency of utilizing this technology. And the rate is from 0 to 1, where 0 means it cannot improve efficiency at all, and then 1 means it can completely replace humans to do the corresponding work. And we did that to measure the efficiency and to measure also the disruption and to measure the AI impact. And then we did that for all 900 plus occupations to get some insight of AI impact. And then this is some sample of the results where it can give you the score, and also will provide some reasons or arguments on this score. And to measure the consistency and the reliability of these scores, we designed 5 different prompts that will ask the same thing, and then we ask it to ChatGPT, Bard, and Gemini to come up with the average of that, and to make sure that we can call this an educated guess of AI impact on labor markets. And the second prompt, it's similar, but instead of asking how it can improve the efficiency, we asked here how many new work opportunities AI technology can create in different occupations. And this is also a sample of the results for one occupation, and the score and the reasons and the arguments for that. So we did that for all occupations, and then we came up with the occupation level score and industry level score. So the occupation level score, which we have above 900 occupations in total in US labor market. So the AI disruption score, it's basically the efficiency improvement because of AI, how AI can improve, how AI can replace this work or can do this work. And then the AI creation score is the new jobs created because of AI, and then the impact score is the difference between these two. And then on an industry level, we also have this weighted average scores based on how many job opening, just like what you can see here. So in the same data set, they will also have the projected job openings, which we took into consideration. And then the number of employees replaced by AI is the number of employees in the industry times the industry level AI impact score. So we found plenty of results, which will be published very soon. But the summary of that, we found some of the top 5 industries, bottom 5 industries that will be impacted by AI. But in terms of the AI impact on cloud forensics, on cybersecurity, which is the input that I want to take from this for my framework is for the entry-level job titles for most industries, it can be replaced by AI, including data analytics and some other job titles. However, when it comes to cybersecurity, because it's really critical, things that you cannot really ask ChatGPT or ask some of the other LLMs, how we can do this specific cybersecurity automation or cybersecurity defense, or how to leverage that, then there is a really need to a cybersecurity specific LLM, which will be integrated in the framework that I will conclude my talk with, and I will present in this slide. So the framework basically will consist of the cloud system that I talked about, which is the application that I migrated to my cloud environment, including this multi-hybrid cloud. And then we have the attacker agent and defender agent. So we have a multi-agent approach here where the attacker can play the role of the attacker and can leverage frameworks like the cyber kill chain, which is this framework. It basically explains the steps that the cyber attackers take to gain access to the resources, starting from reconnaissance, collecting information about the target, going through weaponization, and then delivery, exploitation, installation, command and control, all the way up until the actions and objectives. And this framework basically will summarize how attackers gain access. And then our goal from the defender perspective is to disrupt this chain as early as possible, to, let's say, disrupt reconnaissance, which means that we have to really reduce digital footprint, what can be found about us, what can be used against us. And then weaponization, it's really hard to stop because they're not doing anything to you at this point. They are preparing the weapon based on the information that they found. So if they found that you're using special version of Windows, and then they found some vulnerabilities in the CVEs, which is the common vulnerability exploitation. It's basically all the scripts that can be used to exploit any vulnerability, and it's publicly accessible information, can be used for good or bad. So if they figure out some information and they use this database, then they can move to delivery and so on. So the attacker will leverage this framework in addition to the threat feeds and common vulnerability exploitation. OWASP Top 10, it's a well-known research group in the cybersecurity community where each 4 years they come with the top 10 successful cyber attacks. And then it's also been leveraged from defense and from attack perspective. In addition to the TTPs, which is tactics, techniques, and procedures, like social engineering, or maybe they can change also their techniques to go low and slow in the reconnaissance to avoid being catched by the defender. Instead of going very fast, they can go on a conservative reconnaissance and so on. And from a defender perspective, we will use also zero trust architecture. So the zero trust architecture basically says that we trust no one. So usually in the law, we say you are innocent until proven guilty. Then in cybersecurity, it's completely different. Everything is malicious until proven otherwise. So we trust no one, we trust nothing. And then this is where we want to actually apply this concept or architecture. And also active cyber defense, which is the framework proposed by DARPA to anticipate that we might have some cyber attacks and then to prepare our response based on that. We will also follow a stride-red threat model, and here's what this abbreviation means. Basically, it's how I can categorize these threats, if it's spoofing, tampering, and so on, and how I can give it score based on the damage that it may have for my infrastructure. One of the things that also I'm proposing here in my defenders is the moving target defense, which is basically changing our infrastructure configuration, and by the time attackers go from reconnaissance all the way up until exploitation, then we change our infrastructure, and then they won't have the same port numbers, the same IPs, the same configuration, and this will be one of the defense mechanisms, in addition to deception techniques like honeypot, honey token, and making things look attractive just for us to gather information about attacker techniques, motivation, and so on. So in addition to these two agents, we have the inspector agent and the defender agent, where the inspector will play the role of the summarizer. We're going to have the logging for all the interaction between attackers and defenders, and we'll keep that in our database, in addition to the LLM for cybersecurity, which will help me to give me recommendation more specific to my environment, to what I have in my cloud environment. And the detective will play the role for forensics investigation, where it can really do this automation for log collection and retention, in addition to alert prioritization and the isolation policies that I talked about, where it's predefined policies that I can attach to my infected resources to avoid turning anything off, but also to be able to contain security incidents. So this is the framework that I designed, and it will be part of my graduate level course on cloud security, where the students can play the role of attacker and defender and inspector and detective, and then we will come with some data to also improve and to train our agents here. So I will conclude with this, that in cybersecurity, cloud stands for collective learning and orchestration of unified defenders, whether these defenders are my agents, are the collection of tools, the collection of the collaboration or cooperation between my teams. And otherwise, if we think that it's only a single agent, or we define our security toolkit in a way that will not talk to each other, then we will think that we are secure, but the actual situation is like what we can see here in this picture. Yes, the door is closed, but of course, it's not secure. So with that, I'll conclude this session, and thank you for listening.